Let's consider the following setup showing a vibration generator, a string, a pulley, some masses, and we have, as you can see, a stable pattern where we have regions of zero amplitude, regions of maximum amplitude, what kind of wave is this? What are the names given for the points, regions, where you have zero amplitude, maximum amplitude? How is this wave formed? What is needed? What are the conditions? Can you answer a 6-mark essay on describing the formation of this wave? Now let's consider we want to do an experiment to study the frequency at which this pattern forms for different lengths of the vibrating string, keeping the tension constant. What are the sources of uncertainty in this experiment? Let's look at the variables. We will need to record the frequency when we have, in this case, two loops. How do I identify this? How can we improve the accuracy in identifying and recording the corresponding frequency? In each case, we will need to measure the length. What equipment should we use to measure the length? The string, in this case, is longer than 1 meter. What kind of errors can we make in measuring the length? That will introduce an uncertainty in our value. What can we use? How can we change our experimental procedure to improve the uncertainty, or reduce the uncertainty, not improve the uncertainty, reduce the uncertainty in our measurement of the length? We will also need, although it's kept constant in this case, the tension. We can work out the tension by using mg, mass, times acceleration due to freefall, or if you like, the gravitational field strength. How can we measure the mass accurately? What equipment? Any techniques that we can employ to make sure we eliminate, remove, or at the very least keep as small as possible the uncertainty in that measurement? Let's consider the two different signal generators. One is this one. You can of course have this one. Look carefully at the scales. This is now set to 10 to 110, and there is a scale, so it goes 0, 10, 20, 30, and so on, versus this. Can you suggest any advantages in using this compared to this? What are the disadvantages that this kind of scale will introduce when we try to record down the frequency? Make sure you use the correct physics, terminology, and give a full answer. For example, what is the reading shown? Remember, we have it on 10 to 110 Hertz. Look at it carefully. If we only have this, can you suggest how we can adapt, add additional equipment, assume you have access to the standard equipment in a physics lab? so that we can actually measure, record more accurately the frequency. Let's have a look at using a stroboscope to freeze the motion of the string. As you can see, when the strobe frequency matches the frequency of the signal generator, bear in mind that they may be slightly off due to calibration errors. This is the signal generator driving the stroboscope, and you can see that the two frequencies are virtually identical, 23.3, 23.3, although the signal generator driving the vibration generator claims is 22.9. But this is expected, it's not unexpected. Now, as you can see, we can see at any point the string to be in one position. It may be drifting slightly, but clearly we see the string like if it was not moving at all. Can you predict what we will observe if we gradually increase the frequency of the stroboscope? So it's twice what we have now, let's say 46.6. Bear in mind, maybe close to that, not exactly 46.6. due to calibration errors. So I'm just going to increase this. Keep an eye on the actual string. I'm on 45, 45.3. We seem to be having two positions of the string are now visible. And as I'm approaching exactly 2 times the frequency, the string should become stationary, slowing down, slowing down. We are almost there. There we go. We now see the string at its two places. And we know this is the maximum possible frequency we can see the string 2 times. I know it's drifting slightly, but that's just initial calibration, and also the original, or rather the signal generator driving the vibration generator may not be as stable as we think. I think this is much better. Now it's definitely spot on. So as I said earlier, we see the string at 2 places. There we go. 2 places, although it's slightly drifting. If I keep increasing it, obviously, I will see the string at more places. What do you think will happen if I go 3 times the frequency? So we are now on 66, so let's try and get to exactly 3 times. It should slow down, slow down. Yes, slowing down. There we go, excellent. So we now can see the string at 3 different places at the same time. There is slight drifting, but that's expected. Clearly we have it at 3 different places. Trying to fine-tune the bit. There we go.